Hello, everyone. Glad to be here with all of you and around here. Super excited to demystify the Python and traces for you. And it will be the session with full of hands-on, and we will be touching history of what went in and where we are going and things in between with a live experiment that we'll be performing. So stay tuned. And if you have any questions in between any time, feel free to pass it over to Adam and we can address those questions or concerns or any queries that you have about Python or distributed tracing in general. Happy to answer those questions. And that said, again, I work at Splunk as engineering manager for this team called Forward Deployed Software Engineers. And apart from that, another news is that I am going to be at Data. So that's super exciting, as well as brings a little bit of anxiousness just because it's the first baby we are going to have. In my free time, I help provide coaching and mentorship to the software developers, DevOps engineers, SREs across the industries, go to the next phase of their career, be it having them to acquire a career in being individual contributor up to principal, senior principal, or like in a people management role, like engineering manager or SRE manager. So if you need any help on those regards as well, feel free to reach out to me. We'll discuss more about that as well in a bit. With the, and that said, let's get started. Yeah, so we will cover what is tracing and basics of it, how it all started, and where the industry is right now. So stay tuned. Let me switch over to our slide, which has more information on evolution of tracing. So over to the evolution piece. What you see here is the tracing evolution for in Python. We had Xtrace in 2007 coming up, and then Dapper Pepper in 2010, Zipkin in 2012, and Sky Walling in 2015. And at the same time, Google started funding, and many other industry players started funding open tracing, open census, Jaeger for receiving those traces. And what it has become now is like, oh, now we have so many tracing solutions. What do we do? And now we have this solution called open trace telemetry. So we will be focusing on that and some of the example codes around it. I'll be sharing those codes as well with you so that you can take it with you and implement it in your environment. We won't be covering Grafana tempo, which is alternative ways, just because we want to stick with standardization, which the whole industry is supporting. Like no matter which telemetry or metrics analyzer or traces analyzer that you use, whether it is Jaeger, Prometheus, SignalFX, which is Splunk infrastructure monitoring, or Datadog, or any other like paid or free open source solutions, doesn't matter. All this open telemetry solution that we have here, it kind of creates the standardized language and notion across all the languages. So in your environment, you may have applications ranging from Python, Java, written in Go, and this open telemetry framework helps you consolidate logs, traces, metrics from all across the sources that you have running in your microservices environment, and helps you standardize it. And then it lets you export those logs in multiple ways. So we will further deep dive on like what traces actually means when it comes to uh, like observability. And we will be focusing on some of the terminology and concepts around tracing. So let me just give you a quick background on open tracing as well. We'll deep dive a little bit, and then we will go on hands-on. So opentracing.io is the primary website of the project, where you can find the docs, guides, projects of like, if you want to volunteer and contribute, this is the best open source. I think this is the second ranked CNCF project, first being Kubernetes. So why not support something that's making industry much easier when it comes to tracing? So, and when you go over the docs, it has all this information on overview, how can you get started, some of the best practices, what it supports. It also lets you know what it doesn't support. So and that's the benefit of open source community, right? So you can see here that libraries are available in 9 languages. What we are interested in today is Python. So you'll also have Python repository open as well. And then let's discuss what is distributed tracing, right? So I know this has like a lot of information here, but just to summarize here for everyone, tracing is different than logs that you do through logging library or metrics that you collect from your application, right? And what traces helps you capture is that the flow of your multiple application across the containers or across the microservices. Even if you have monolith like brownfield environment, you can still use traces to track down your gigantic monolith application and see what's breaking, where you need performance improvement, where can you find scale issues. So those are the why you would want to use tracing, right? And like what makes tracing interesting is that it helps you visualize all the components, such as let me share one interesting piece with you. Basically, let me share this with you. Tracing with Python and what it comprises, right? Like how does it look? And like what is span? What is network trace? So all those questions we are going to answer today. So one being trace is a full collection of your API calls, your database calls, how much duration your database query took in order to get the query resolved, as well as like span and network call span needed, like duration. And the overall overview of all this collective miniature details makes a one trace. And then when you make calls, we have an interesting microservices app we'll be running here in a bit. So when you make an HTTP call on your services, where all does it touch in your backend, and what all services does it go through, what all databases does it query, where is that performance improvement that I need? So trace, observing the trace helps you identify those issues. Let me know if you have any questions so far. So far it looks good. So we can go ahead and we can probably see what trace looks like in the real world, and how do you observe the application, right? If there is a trace available, what would you do? How do you measure it? So without any ado, we will go and dive into code base. We'll share some of the Docker Compose files, Docker files, as well as Python application. And we'll go through the code review on how it looks like from the higher level. All right. But before I go, I want you to like visualize how like one tracing call look like. So maybe I'll share one really quick URL here for you so that you can all see. So this is the Jaeger image, okay? So what you see here is a trace for get dispatch call here right now. And you can see here that it's touching front-end service dispatch. And once dispatch is called, it's accessing customer, and it's making another get request. And then there is a customer call as well, and then database query. So that's just one part. And there is another front-end call to the driver to find driver detail, which is the nearest driver here, right? So this is more like finding driver from the database query in Redis. And you can see here, there are like red alerts. So this is a Jaeger interface that you see. So this red alerts means there is something wrong. Either the query is slow or it's failing. So when you go to right-hand side, it shows exactly what amount of time each request on the left-hand side took. And it kind of gives you an ability to see, oh, this first request is actually taking 733 milliseconds, out of which this one seems like all of these are taking 8 to 10, but this one specific query is taking 32 milliseconds, and it's also causing some error. And the ones that are causing error, you can see here, they are creating delay. They are doubling or tripling the delay in your application. So those are some of the performance improvement or code error checks that you can investigate quickly. And let's go back to the code base that we have, and then we'll go over the application that we have, what it pertains to in terms of OpenTelemetry, Python, and distributed tracing. So let's get started. One more important aspect is OpenTelemetry. So OpenTelemetry is basically sum of open tracing and OpenCensus. Those projects are kind of discontinued. So what we saw here is like something which encourages you that, hey, you use OpenTelemetry. So you will see the naming convention, and you might have seen that we get confused all the time between open tracing, OpenCensus, OpenTelemetry. Just keep in mind that what you will be using is telemetry. Even though you will hear the word that, okay, we are getting the traces, you are using OpenTelemetry, and the open tracing and OpenCensus project are being discontinued slowly. And this is another website that you would want to kind of bookmark and remember for the best practices, like in your production environment. Just note that these solutions are not only for like big corporations. Even if you're a startup or mid-sized company, you can still leverage these solutions, and you can send this. And what OpenTelemetry does is that it allows you to give like SDK or API that you can implement in your Python code, like whether it is a Flask app or Django app or any other application or command line tool. It lets you integrate open telemetry easier and more efficient way, so that once it's integrated, there is a component called open telemetry exporter. So what it does is that it allows you to receive those telemetry from your Python file and into the destination or exported destination that you wish. So you can see here, like, use this to instrument your code and generate and collect and export telemetry data. And we are talking about traces, but open telemetry lets you work with metrics as well as logs. So, well, why not use something which is becoming industry standard and more like, and which supports open source software, right? If you want to export this solution to some AWS services or AWS-based APM or in GCP, you can do that. You want to export it to Splunk SignalFX, Datadog, you can do that. So again, like just reiterating that you get that liberty and control to export it without like remigrating or rewriting your application. So those are some of the benefits that you get. And if we go over the docs, this is one of the concepts I would really like for you to go over. So open telemetry agent sits aside your container. So that's one way of deployment. What's the other way of deployment? Well, you just install open telemetry library that can be installed through pip or poetry, whichever version control or package management tool that you are using in your distribution. You can use to just import those open telemetry library, and your application will be able to collect and send those logs, metrics, and traces. Where does it send now? So generally, it sends it to hotel collector, which is a service or a sidecar, again, another container that's running, which takes care of translation. Like, hey, there is a trace that came from Python application, collector receives it, and then either it can be sent over to different application, or it can be sent over to like final destination that could be Jaeger or any other APM or trace monitoring or trace analyzing backend service that you will have. So this is just the reference architecture that you have. We'll also go over collect some of the concept that we have, so that we don't get a lot of confusion during our hands-on. So we covered a bit of what is OpenTelemetry, but this documentation is really, really verbose. And I would encourage you to just go over it and just get some enablement on, like, why do I need hotels, right? What can it do for me? What's the value for my business or for my developers? For business, it's more like visibility, and like you can reduce your service level issues that you may have, or like MTTR metrics that you may have, so that you get more improvement in your environment when your maturity of your business increases, when your applications are performing reliably, and when you can identify problems early on. So also, it's important to know what open telemetry is not. So open telemetry is not the observability backend. So what that means is that it doesn't replace Jaeger or Prometheus or any other point solutions like Datadog, Splunk, or something in GCP APM. So it doesn't replace those backends. It just gives you the standardization that is accepted across this open source observability backend as well as paid services. So just keep that in mind, that OpenTelemetry just simplifies the collection and export of the telemetry data and metrics and logs. And you can see that here it supports exporting data in a various open source and commercial backends, so that that kind of gives you some idea, and we will go over those as well. And now let's go over next to components. So components contains SDK and API, and that's something we covered already. Data is basically the information that is being passed from one method of your Python function to another function or another endpoint of your Flask or Django application. So that data or that method that's passing that argument of data is written in this OTLP protocol. So OpenTelemetry line protocol. And it's still, again, open source, it's vendor agnostic, and that's what you want to go for when you're building your tracing needs, your telemetry needs for your in-house applications. So they say specification, we will be using API and SDK in our hands-on. We have collector. So collector is what helps you accept or receive those OTLP messages from your application, and then helps you export those into multiple formats, right? It helps you receive it in multiple formats, and then it helps you also send you to more than one backend. So this part is also very important. Say you are migrating from Jaeger to Prometheus, or Jaeger to Splunk infrastructure monitoring or Datadog. This OTel collector will let you define more than one output destinations, or more than and also fallback, right? Say one of the destination is failing, it will fall back to the failover destination or output location that you have for sending data. It also helps you during migration, again, reiteration of what we said about that output feature. Language SDKs, it does support not just Python, so many other programming languages. Again, we will focus on Python for our demo as we do the hands-on, but you can have OTel implemented in any possible language. It does have automatic instrumentation, and what that means is that all you need to do is import some of the SDKs and modules and wrap your existing code with just tags like with statement in Python, and it just converts your existing code to allow it to trace back in the Python in the backend when you are exploring the data or traces through Jaeger. So there is that. And data sources, I don't think we have to worry as much. It just explains what trace is, what metrics is, and what logs is. Let me know if any of you need more deep dive or clarification on each one of these. We will touch base on this as we go forward, but yeah, feel free to let me know if you need clarification on why there are just so many this jargon for data or this information, right? It's just that like getting some abstraction across the data makes it easier for the backend applications to understand which type of data I'm receiving. And when I'm debugging some of this, what should I look for? Should I look for logs? Should I look for metrics, which are generally focused on resources like CPU, memory, disk space, network utilization, etc. Or should I look for traces, which are tailor-made, very specific to your application? You have defined those. So that's one big difference. Like when you do Python logging, and if you are forwarding your logging through OpenTelemetry, it will be those like log.info or debug or error or warning that you decide to send, right? And that's what log is. Like you will be sending that, writing those statements manually, maybe sending exception when exception happens, right, to the backend service. But metrics will be just the telemetry around where your application is hosted and how does the CPU look like? What's the memory? Are we having memory leaks? Are we having network congestion, right? Or do we have disk space, or are we running out of it? So it will let you predict before your like backend disks, or like if you're using Minio or S3, that's less of a worry. But if you're still having those hosted in an environment where you want to monitor those health metrics are the ones that you would use. And traces are the one which you would use for your custom context, right? Custom metrics like custom information and labeling in your definitions in Python application. Let's see one quick example, maybe Python trace open telemetry, and we can probably see the package and see how the code looks like, right? So it will give you some more idea rather than us just going through this documentation. So this is one of the open telemetry trace package that we have as a documentation. And what you see here is the simplest form of generating the trace for your function do work, right? And what you have here is you're importing trace from OpenTelemetry module, and then you are defining trace through trace.getTracer, and giving it a name of the application that's running it. And then you have the tracer handler that you would use going forward to append tracing to any of your functions or any of the logic that you may have in your code base. So generally, trace has the concept of span, and span is like duration that it took for certain instructions to complete. Now, in old school ways, what we used to do is like add timer and just count like, hey, from start to end, how long it took for my function, right? This is like 4 or 5 days ago, 4 or 5 years ago. We used to do like timers. We would just add timers and say, oh, it took 10 seconds for my function to complete in this situation. And then you would do logging, and you would have custom logging to forward it or just save it in the file system, and then you would analyze the file. But what tracing allows you to do is when you add this with statement here and just add a span keyword, maybe parent, this is maybe like something like, okay, I'm processing the customer order, and this is maybe in the customer order, or maybe your purchase orders, right? This is more like you are just verifying the payment details. So it would give you visibility per trace that you have defined, how long it took for the whole customer order to complete. And then inside the customer order, how long the payment piece took, payment verification or payment processing. So all these are the benefits that you get because you are getting this telemetry in real time, right? And this is again one of the other example to set the context in the span and try finally like different way of defining trace in your application. So here we use the with. Here we are just using try and finally. And what we are doing here is we are passing the span in the do work function that we have. Now there are few new things that we get to explore in the newer version. So feel free to go over the documentation. After this, we will be also having you, go over the GitHub repository so you can access the source code afterwards and play with it and use that as experimentation or more like test environment before you implement this in your application. So documentation is pretty verbose. It explains you information about traces, span, like parent span, child span that we covered, right? Order, and then payment processing example. Now, let's go over the hands-on without any ado. I know we have covered like quite a ton of information. So I will go ahead and switch my screen and we can start working on the hands-on part. And let's also give you all the resources so that you will have those information. All right, let me switch over to my terminal and VS Code. You will see some application running and some code base. So we'll go over both of those. So what we have on the left-hand side is one application that's already running. We will slowly take it down. It's based on Docker Compose, easy to convert it into Kubernetes if you wish. I generally prefer Docker Compose when you are experimenting in your lab environment. And if you want to give some solution in a real quick manner, and especially for those who are just starting their container journey, this becomes super helpful because think of Kubernetes as like containers on steroid, right? Like you are having an ability to orchestrate containers, like how many pods you want. Within those pods, how many containers do you have? And the nodes, right? Which is the topmost part of your infrastructure inside the Kubernetes. And then you would have like context and namespaces to separate all the infrastructure and microservices that you may have in your environment. So like removing those complication of orchestration and just focusing on Python and how we can add telemetry to Python. When you add these containers into Kubernetes, it will behave same way. It will just give you more verbose information just because you will have multiple containers running in your environment. And we have a t-shirt company example here. So I will start this service again and see what we have. So we have an application, we have Jaeger running. All open source software, there is no payment or any purchase that you will have to make in order for this to run. Just make sure you have Docker or any other container environment installed, like even Podman, for example. So now that we have this installed, let's see how it looks in the UI. So let's go over localhost. And that's my local host here. And we have one service running here, which says it has t-shirts in there. Now, when you make refresh or make any calls here, you will see the left-hand side. We are getting the requests on the home welcome page. We click on one of the t-shirts. It does make calls on subscription. If someone wants to make t-shirt subscription, right? This is a t-shirt subscription company. So the pretty basic application. It has like some inventory of t-shirts. It has a home page. It has a custom handler as well. So let's dive into the code base and see what we have here. So I will show you the most important pieces, what you may want to focus on, and we'll ignore the noise. So we have Docker Compose file, and it has your t-shirt app, which is your Python application. So you may want to focus on this code, on how it's instrumented. And you see here how it has Jaeger here. It depends on Jaeger. And this Docker Compose file is written in YAML format. And then we have Jaeger service, which also has image of its own. And it is exposing some of the ports to the remote host. You don't generally have to expose all the ports. You may want to just export port, which is responsible for the web services in Jaeger, and we will see that as well. So this 8E80 is the web service that Jaeger runs on. And left-hand port is the WAN side or your host side port. Right-hand is the one that listens inside. So you generally don't want to change the right-hand port unless you change it inside your application, inside the Jaeger or inside the Python. You can always change the external port. So that's the spec file. There are some of the other things like volumes and networks. Just comes with it. Let me know if you have any questions or want a deep dive on it. But otherwise, now we will see the Python code and application and how it actually is structured. So that's the t-shirt company directory. Inside that I have source. And then I have some of the app, my packages test, simulation, yada, yada, yada. And remember, Docker Compose it helps you run multiple containers. But if you want to build containers, you would use Dockerfile. And this is our Flask application. It takes the Flask application as like Flask image as the root, and then it does the updates and then runs the pip as usual. The things that we do manually for monolith application, this encapsulates everything into the container and it builds the image for you. Now let's go to the source code, because that's where the meat is and that's where all the implementation has been done. So I will actually maximize this window a little bit so we can focus on it. And you can see here we have Flask application here. Some of the functions are not being used. So VS Code is very friendly to identify that, hey, you are not using this. What are you doing? You're not using this. Why are you having those things? And then we have some of the import function. Where I want you to focus on is this part. From app hotel, import everything. Now you can import specific things or just have that code base of hotel right in the application. We'll go into the hotel part, but I'll first show you what the application does. So we have Flask application defined here. We have static URL path for all the images, CSS files, right? And then we have static number of the JPG file. There is no backend or anything. Very simple application. And then we have two.
We're not seeing your code right now.
Oh, I see. Let me make a screen share.
Okay.
Thank you very much.
Yeah, no problem.
Informing. I think you should be able to see.
There we go. Much better. Yeah. Thank you.
All right. I will go back and share the Docker Compose file. So this is the Compose file we were talking about. It has application, Jaeger node. It has hot rod application, which is for testing as well. If you want to test some more telemetry. And t-shirt company is where our Python code is. Inside t-shirt company, we have source. And we also have Docker file. So Docker file is what helps you build the image. And then we have our main Python, which has Flask application, which has Flask application with static paths, t-shirt lists that you see in the UI. Now, you might not have seen t-shirt list as well. So this is what we were talking about when I was referring to t-shirt list. So this is the very small microservices application. It has home page, it has subscription page, and there are custom endpoints for backend activities. So there are two custom endpoints that we have defined where we have tracing enabled. So you can see we have tracing enabled, which says for request 2. Here we have tracing enabled, which says foo. And when we hit these applications, we'll have trace generated, and it will tell us how long it took for this request to come. We have other endpoints in our application. I'll quickly go over those, which is just root, HTML, our good old hello world, right? And then for home, we have a router to static file. So our home here that you see is being served by static file, and it has a Jinja template to replace these images dynamically that we have received in this array. And then we have subscription endpoint, and then subscription backend endpoint. And our application is running on port 80 with a debug mode on. Now let's focus on hotel part. We know that it can be defined through with statement, and you add the tracer and you add the span name, and you can say, okay, this is the request one. And you would ask, like, what's the bare minimal do I have to do in order for this to work, right? So this is the hotel class I have. This Python code has all the dependencies that has been imported. You can see that the ones that's in gray area, gray color, we are not using those. So we have import trace, we have import trace provider, and you can see that we have also imported Jaeger specific some exporter. So just to make sure that Jaeger understands some of the information. And sometimes you don't need your hotel exporter, you just use Jaeger to export your services. So this is our Jaeger exporter. And what you do to define your trace and initialize it, you set the trace provider, and under the trace provider, you say, hey, my resource is a service name, and this is my service name. And then you'd want to also put batch process. So when you are getting traces, you don't want to probably bombard the Jaeger services. So if you want to do batch like processing, you can define your Jaeger exporter agent name. So this is the host name that we have in Docker Compose right here. So in Docker environment, when it runs this application and Jaeger, when you are like shelling into getting into TTY, when you ping Jaeger, it will ping this host. So name that you see here implies that it's also network host name. So when you define this name in your application, it will connect to these ports that's defined in the Docker Compose. Just remember those things. And
we have about 1 minute left.
Awesome. Thank you, Adam. And then we have batch processor here, and then we are adding the span. So all this gets imported in our main function right here. App.hotel import star. It gets defined here. And you can just, so this is the verbose version of a tracer, and this is the simplified one-liner. So all you have to do is encapsulate your request with, and it would just work out of the box. So if you have this backend service here, right, you can just say with, and then just adjust the indentation, and you will have trace for the t-shirt ID. So you can say this is trace for t-shirt ID. Now let's go into the terminal and run our services and check the error. So our services are running. We have our t-shirt company running. We also have our simple floral design t-shirt, or all these options that we have running in the service. You click on those, it dispatches and creates trace. So this is a trace ID, and it tells you how long it took in the Jaeger. So this is the Jaeger interface. Now, when you click on find trace, you click on find trace here, and it shows you what happens. So let's maximize this and see. So this is a Jaeger UI backend. What happened is code came.
Mayur, I do need to cut you off. I'm sorry, we are up against time.
So in case you have any questions, this is the slide you want to focus on, and I'll stop sharing and take your question. I'll join the live session and we can go from there.